Welcome back to part 8 of the silver cell anode filters recovery and refining series of videos. Here's our filters with the mystery precipitate. I'm going to set this out of the way. Here's our filters with our filter cake and the black solids after we removed all of our silver. Captured this in a filter paper. So I'm going to move this out of the way, and then in here is the solids from the final nitric acid boil. Not quite sure what this is. I was going to add this in with those other filter cakes, but decided not to. So we'll process this later on. I'm going to set this out of the way, and I think what we're going to do is we're going to start with the DMG precipitate that we captured in these filters. What I would normally do with these precipitates in these filters is just go ahead and start adding some aqua regia to this and start dissolving this material in aqua regia, but I'm going to try an experiment here, and there's probably a little bit of silver nitrate left in these filters with the precipitate, and silver nitrate is highly soluble in water. I don't think the yellow precipitate is soluble in water, so I'm going to begin this experiment by adding a little bit of this distilled water to these solids in this beaker here. The reason I'm going to try this is to see if we can get some of the silver nitrate to come out of solution, or to go into solution, or to rinse off actually in this water before we go and try to dissolve this in some aqua regia. See what happens here. If it doesn't, then I'll just add a little bit of hydrochloric acid to this, and we'll dissolve it as we usually do. First, let's see what happens. See if we can get a little bit of this silver to come out of this solution. I'm going to add some gentle heat. Just heat this up a little bit. The purpose of this experiment is to try to get some of the silver nitrate that still remains in those filters to go into the water and get it away from the yellow precipitate. This has been on some hot water now for, well, about an hour, I guess. And so now let's see if we can get a sample of this water and check to see we have any silver in that solution. Turn the heat off and let this cool down and let this settle out. Allowed this to cool completely. So now what we're going to do is we're going to try to filter off some of this liquid. Let me wet the filter first. Hopefully any silver nitrate that remained in those filters will get dissolved by the water, and the yellow precipitate will not dissolve in the water, and so we can separate the silver nitrate from those yellow solids with distilled water, hopefully. Now I'm going to get a sample of this liquid. The beaker, it's got a little color to it, but not much. And what we'll do is test to see if we've got some silver in here. I'm going to add some hydrochloric acid. If If there's silver, it'll form a cloud of silver chloride. If there's a whole bunch of it in here, we'll do another water boil until we get most of it out. But if there's just a little bit, then we'll just carry on from here. Here we go. Let's test it out. Oh, look at that. Got a ton of silver in there. That's a ton of silver. Now what we'll do is put our funnel back in this bottle here. And I'm going to try to get all the filters and everything else out of here, down into here, so we can rinse it off while we got it in this state. If this stuff will fit in here. Was right. The silver chloride is soluble in this water, but the precipitate, the yellow precipitate, is not soluble in the water. So we're getting a good effective separation of this silver that's in solution, silver nitrate, from our precipitate. So I'm going to rinse this off. I'll add this to the bucket, cementation bucket. We're going to rinse this off now with a little bit more distilled water. Try to get as much of the silver rinsed out of here as we can. This is a critical component of refining these metals, using a solvent that will dissolve one compound and leave the other compound behind undissolved. I'm going to draw a sample right off the funnel here to our little beaker. See what kind of concentration of silver we got in here. That should do it. Adding some hydrochloric acid. Still got a little silver going on in there, but not as much as before. I think what we're going to do is maybe give this material another boil and see if we can pull some more silver out of here. Put it right back into the same beaker that we used earlier. Boom. Adding some more distilled water. Set this up on the heat, cover it up, and do another hot water boil and see if we can get more of that silver out of there. All right, we've had this stuff boiling for a good bit now. So what I'm going to do is shut this down, turn the heat off, and let it cool down. I've got this cooled off, and we're adding more paper here to the process, but that's okay. It'll just disintegrate when we go to start refining this material. And what we are doing, though, is getting an advantage because we're getting rid of some silver chloride out of this material. Let's draw a sample of our rinse water here and see if we've got a decent result. Can add a little bit of hydrochloric acid to this. It's got a little bit of cloudiness going on all by itself, but let's see what happens with this hydrochloric acid. I still got a little bit of silver in there, but I think we're going to be okay. You can never get 100% of it, but that's much better than when we started. I think we'll rinse it one more time, just for good measure. I will transfer the yellow precipitate to a clean beaker. I'll put this solution in my silver cementation bucket and get whatever silver is in here out by cementing it out on copper. I'm ready to start the refining. What I'm going to do is add about 200 milliliters of hydrochloric acid. I'm going to add in a little bit of nitric acid to form aqua regia in here. I'm not adding any heat yet. And what I'm going to do is put this on time lapse and just let it go real slow, because this material is notorious for having a runaway delayed reaction when I add the nitric acid. I've been taking this real slow, and what we're going to do now is reach in here and get some of the solution on this filter paper and do a stannous test. See what we got going on in here. And there you can see, got us a nice stain. I can see some green in it, which means palladium. And I can see some orange in it, which means platinum. I'm going to add a few more drops of nitric acid, just a little bit, half a milliliter, if that. I've got some hydrochloric acid in a squirt bottle. I'm going to rinse down the inside of the beaker with some hydrochloric acid. Now I'm going to crank the heat up a little bit. I'm going to try to get this solution nice and hot. See if we can get the rest of the precipitate to dissolve completely. I think we've got everything to go in solution now. I'm going to turn the heat off and let this cool down. It is the following day, and I've let our solution cool completely. If you look down there, you can see there's a layer of sediment down on the bottom. That's all the old filter papers that have settled out. And what I'm going to do here is I'm going to reach in with a piece of filter paper, get a little bit of the solution on our filter paper. And what I'm going to do now is put this on time lapse. We're going to test the solution on the filter paper with some stannous chloride. I'm going to set it on this paper and put it on time lapse, and you'll be able to see the change that takes place as I do this. I hope that demonstration of the stannous test on this material was effective for you. The green indicates that we've got palladium in solution. Now what I'll do is filter our solution. I'm going to use a gravity type filter here. I'm going to wet the filter with some hydrochloric acid because water tends to form some strange compounds with this kind of material. And we're going to go ahead and pour this through a filter now. I was trying to minimize losses by using a small filter, but I realized after I got going here I didn't use a big enough filter because I had all those solids that needed to go into the filters. And here I'm using hydrochloric acid to try to push some of the solution through the solids that's in the filters.
I'm using pure zinc metal to reduce the platinum and palladium out of the solution.
I thought I had it in a big enough beaker, but I didn't. It overflowed, so I had to transfer the solution that overflowed back into the beaker after I changed out the dishes.
Okay, this is our mixed black PGM metals. It's going to be a little bit of platinum, a little bit of palladium in there. Still a bunch of zinc in here. Gonna have to dissolve that out with some hydrochloric acid. Distilled water to make a dilute hydrochloric acid solution.
Okay, we have the metals cemented out on zinc. Going to pour off this waste solution because the metal will try to go back in solution. So I'm going to get this acidic solution off of here. Still got a piece of zinc in there. That's okay. That's a piece of zinc. Rinsing it off with some water. This is our final product. This is the black PGM powders, platinum and palladium, that we recovered from the DMG precipitates that we got out of the silver solutions. It's not very much, maybe a gram and a half or so. And I'm just going to hang on to this now. And what we'll do is we'll process the black filter cakes and pull the platinum group metals from those black filter cakes, add this to it, and then do a complete refining. So this will conclude part 8 of the anode filters recovery and refining series of videos. Thank you for watching.